Vast majority of diseases, they are polygenic disorders. It means there are mutations in many genes, and these diseases are more frequent, they are much, much less severe, and they can be controlled and prevented by epigenetic factors.
Welcome to the Hope and Help podcast, where we talk about science and science-based tools to help those that are dealing with chronic illness and fatigue. I'm your host, Haylie Pomroy. I'm a #1 New York Times bestselling author of The Fast Metabolism Diet and many other books. I'm back in school, you guys, finishing my PhD in Neuro-Immunology right now, and always a fierce advocate for those of you that need some help and a lot of hope. Today, we're going to tackle the subject of epigenetics, and I would not do this without Dr. Nathanson. Dr. Nathanson is an associate professor at the Institute of Neuro-Immune Medicine. She's also the director of our genomics group. Dr. Nathanson, thank you so much for coming back. After your last episode, people had so many questions about what is the heck is epigenetics that everybody's talking about, and what does it mean? What can we do? How can we influence it? And so thank you for being here.
Thank you for having me.
It's always a great conversation. And I think distilling down, what is the difference between genetics and epigenetics? I know they both have the word genetics in it, but they seem to be very different. And can you help me and all of us out here understand what is the difference?
It is very easy. When we are talking about sequence of nucleotides in our DNA, It is genetics. So genetics, it is what we have in our cells, sequence of nucleotides in our DNA. Before I say what is epigenetics, let me do 101 in genetic information flow. So all information is coded in our DNA. Then in our cells, DNA is transcribed into RNA, and these transcripts, RNA transcripts, they are templates for protein synthesis. Okay. And proteins, they are workhorses in our cells. So all information about these proteins, about these workhorses, is coded in our DNA. So every cell of our body has full genome. Every single cell, maybe except of erythrocytes, has full genome. But brain cells synthesize proteins that are specific for brain, but not for liver, not for kidney, right? Skin cells synthesize proteins that are specific for skin, but not for brain. So how it is done? It is done with the help of epigenetic regulation. So what is, when we say that, so proteins are coded by genes. If protein that is coded by genes is synthesized, so we say that this gene is expressed. If protein or RNA that is coded by some gene, these molecules are not synthesized, we say that gene is silent. Gene is silenced. So what is epigenetic? Epigenetic, so expression of our genes, meaning synthesis of proteins, synthesis of RNA, definitely is regulated by our genetics, right? If there is some bad mutation, it may be protein or RNA may be not synthesized. So genetics definitely regulates gene expression. And we remember that genetics, it is sequence of nucleotides in our DNA. Right. But there are also other epigenetic factors and epigenetic factors that regulate gene expression. These epigenetic factors, those are factors that are not dependent on sequence of nucleotides in our DNA. So many different factors that are not connected to sequence of nucleotides in our DNA, and they regulate gene expression. They are called epigenetics. And it can be molecular modification of our DNA, the same sequence of nucleotides, but some cytosines are methylated or hydroxymethylated. The same sequence of nucleotides, the same genetics, but some nuclear proteins, they are methylated or acetylated. Again, the same sequence of nucleotides in our DNA, no change to genetics. Actually, we cannot change our genetics. But some non-coding RNAs, some regulatory RNAs are synthesized, and they govern expression of other genes. So what proteins and what RNAs are synthesized in our cells, it depends not only on genetics, but also on a lot of epigenetic factors like weather, financial situation, psychology, exercise, not exercise, definitely diet, microbiome in our gut, which depends on diet. A lot of different epigenetic factors. So all these factors that do regulate our metabolism, but they're not connected to sequence of nucleotides in our DNA.
So no matter what, the sequence is going to stay the same.
Yes. We cannot change our genetics, but we can change our epigenetics. As it is said, genetics is a gun, epigenetics is a trigger.
Yes. Okay. And so I like that analogy, and what we put in, it decides whether something is triggered, correct?
Yes. Well, we have to make step back. There are some diseases, single gene diseases like sickle cell anemia, right, or cystic fibrosis, when there is gene mutated, both alleles, both variations of this gene
and is that in mutated. The DNA?
Yeah, this is in DNA.
Their genetics.
This is genetics. And yes, disease is there no matter epigenetics. With use of epigenetic factors, we can maybe make this disease easier. So there are some diseases that we cannot do anything about them.
And that's a genetic disease. It's in the coding. It's not going to be changed from an epigenetic perspective. So epigenetics, is epigenetic triggered by environmental influence, or is the environmental influence the epigenetic? Do you know what I'm saying? Like when you say weather, we would say that weather turns something on or off in the body?
Yeah, it can happen, yes.
And so if a person, can you give me an example of a disease that would manifest as an epigenetic response?
Actually, almost every disease, right. Almost every disease, not almost, almost every disease, why I'm saying almost, except of these genetic diseases, single gene diseases. So one more step back. These diseases that I mentioned, like cystic fibrosis, sickle cell anemia, Huntington, those are one gene diseases, known one gene diseases. Offset of these diseases usually is very, very early in age, well, except of Huntington and some other. They are very severe and they're very, very, very rare. Vast majority of diseases, they are polygenic disorders. It means there are mutations in many genes. And these diseases are more frequent. They are much, much less severe. And they can be controlled and prevented by epigenetic factors.
Wow. Okay. So what you just described is huge in the body, right? Because we don't have to be, everybody, or we hear so many people say, well, I have high cholesterol because it's familial, or I have obesity because it's familial. So they feel like it's their genetic destiny.
It is maybe genetic, but not destiny.
Thank you. Yes. So something has to turn it on or trigger it. We're seeing this a lot in autoimmune disorders, and we're seeing especially in women having a lot of the pro-inflammatory disorders. And is that because a lot of the inflammatory, I don't know the right term, you got to help me with this one. can get turned on because of the second X chromosome, like a lot of inflammatory responses are there. Okay, there's it's what everybody's talking about. It's because we have two X chromosomes in women.
Yeah, yes, we do have two X chromosomes, but it has nothing to do with diseases.
Okay.
Yeah, it has nothing to do with diseases. Lifestyle does have to do a lot with diseases. Diet has to do a lot with diseases. And those are epigenetic factors.
And so I love that you brought that up, because I think so many times people think if I have maybe a predisposition in my family, and we can't out-medicate that.
No.
We have lifestyle.
Yeah, predisposition can be there. Yes, we all are predisposed for something, but it does not mean that we have to have it. Change diet, take out carbohydrates, start exercising, walking. Magically, many of these.
Diabetes, gone. I have a client that we went down 50 points in her blood sugar consistently. She's on daily monitoring in a week and a half, by rotating her food, using whole foods, getting out the packaged foods. And I mean, it was week 3 that she finally had enough energy and had her food organized enough that she could incorporate exercise.
Yes.
But
it is epigenetic factors.
Yeah.
Yes, I also know some examples when person was taking 8 pills a day, and then after changing diet and lifestyle, within 2 months got rid of all these pills.
Right.
Yes, it is all epigenetic factors.
I believe that, and I see that clinically, but it's really important to understand, and for all of us in our community to start learning more about our bodies. I think knowledge is power. And one of the reasons why I love to bring you into our community is because you come from such a highly skilled aspect of science. Like, not a lot of us want to understand, have the brain capacity to really embrace genetics.
Okay, so I have to tell you, I also don't understand a lot of things, and in general, we don't understand a lot of things. We know very, very little still. We know very, very little about genetics and about epigenetics, but there are some life laws that we observed, and we kind of know that it works.
Well, and one of those life laws is nutrition and movement. I mean, I had a client the other day that was talking to me about they love their dog and they want their dog to live. You know, they said, what do you think, why they were asking me, we're just having this conversation, what do you think the longest that I could have my dog alive? I love my dog so much. And I said, well, let me ask you this. What would be the 2 most powerful things that you would do to keep your dog healthy and alive? And she goes, well, you know, I do whole foods, whole organic foods for my dog, and we walk every day. So I'm thinking, if I keep all the chemicals out of the environment, I don't use the flea stuff, and I, don't use the toxins, and I do whole foods, and I this and this and this and this, that my dog's going to live forever and feel good. And I said, well, could you apply that to yourself too? Could you treat yourself at least as good as you do your beloved pet? So I want to take it back. When you talk about monogenetic and polygenetic disorders, is that when you're talking about diseases like sickle cell anemia, is that monogenetic?
Yes.
Okay.
It is mutation in hemoglobin gene.
Okay.
And it is recessive disorder. Okay. If we don't go into details. So we have usually 2 copies of our genes, of each gene in our cells. If both copies are mutated, there is this disease. Nothing can we do.
Okay. And a polygenetic disorder, does that usually have an epigenetic trigger, or?
Yes. So polygenetic disorders, when we're talking about Alzheimer's, Parkinson's, they are considered as polygenetic disorders. There have to be multiple mutations and multiple genes. And yes, those diseases are regulated by epigenetic factors, many epigenetic factors. We don't know about all of them yet.
No, and we're hypothesizing, but we do know that you can't out-medicate a bad diet for sure. Otherwise, we would, because it'd be a lot easier. We've tried for decades. What do you think about that individuals are starting to get a lot of direct-to-consumer or their own genetic testing done?
It is interesting. Out of curiosity, why not? If it is available.
So what do you think about individuals that are getting, they're showing that they have that predisposition to cardiovascular disease or predisposition to heart disease? Do you think it helps them make earlier interventions in their lifestyle or be more dedicated to lifestyle interventions?
Maybe we are very different with different psychologies.
That's true.
So maybe if for someone it makes difference and it will help to make difference in their lifestyle and diet, why not? Sure. But to make changes in lifestyle and diet, you don't need to do all these testings. Yes. But out of curiosity, why not?
I think that, I love that there's more and more conversation about the impact of stress reduction, about the impact of mindset, about diet, about lifestyle. We had an autoimmune specialist that said, best intervention on a scale from 1 to 5, 5 being the best. And we're talking pharmacological, and he said the top one is diet, right? But when an individual, like so much conversation right now is talking about methylation, and everybody's talking online about MTFHR, and that, if you have this snippet, you don't detoxify efficiently. Is that stuff that's a good thing to know, that maybe you have a deficiency in something or a reduction in capacity for something?
Every time I would start with changing of diet and some more activity, physical activity, and then maybe to think, well, these green leaf veggies, they have so many elements that would serve as perfect medication.
Yes. Isn't that true? And I just think someone that understands, so our very fabric of what makes us human. I love that you study and do research in the science that makes us a human being, right? Is our genetics. I mean, we're not another species because of our...
Let me give you one example. So several years ago, I was at one seminar, and this group presented mouse model of Rett syndrome. Rett syndrome, it is physical mutation on X chromosome. Boys don't survive at all. They're not even born. Girls survive until teen years. It's very severe disease. So mouse model, mice with this mutation in X chromosome. So this group, they had 3 cages with mice. Healthy mice, 1 cage healthy mice, 1 cage sick mice with this mutation. And in 1 cage, they caged together friendly healthy mice and sick mice. So healthy mice play their mouse toys, running in this wheel and play all these toys. Sick mice, you could see they're sitting and shivering. Now, in the cage where both healthy and sick were caged together, sick mice, they tried to mimic their healthy brothers and sisters. And you could see that they're sick. So this mouse would come into wheel, maybe make 2-3 steps and sit, make 2-3 steps and sit, but try, yes. Some could even come to wheel from the wrong side, but they tried. So then these scientists looked at DNA methylation in brain of these mice. And they found that pattern of DNA methylation in sick mice that were caged together with healthy mice was much closer to the pattern of DNA methylation of healthy mice. So sick mice, they had 6 mice that were caged separately. They had absolutely different pattern of DNA methylation. So this physical activity mimicking of healthy mice, they changed modification of DNA in their brain.
So
epigenetic, yes. It did not change sequence of nucleotides. Mutation still was there.
Right. but it made their overall health improved. And I think it gave me two things to think about that. One, it's so important who you surround yourself with.
Oh, yes.
Right?
Yes, it is very important.
What you eat, what you hear, what you speak into truth, what people tell you about yourself. I always say people have a lot of opinions about me. Only the good ones are my business. The rest is none of my business, right?
Good for you. Good for you.
But the other thing is activity. So if an individual feels like they have a genetic destiny, I love what you're telling us, which is it doesn't have to be our genetic destiny.
In polygenic disorders, which are majority, all our disorders, except of very rare, really genetic diseases. It is genetic, but it is not, maybe there is genetic component and sometimes pretty strong genetic component, but it is not destiny. And it was shown also on studies of twins, monozygotic twins that have identical genotypes. And if they were in different environments, so it could make effect on their health.
And that's epigenetics.
This is exactly epigenetics.
So is it nature versus nurture?
Yes.
Okay, that's cool.
Nurture versus nature.
Nurture versus nature. Yeah. So nurture. So I just wanted to clear this up because there's so much going on about genetics, and so. There's a lot of fitness people out there. There's a lot of people in the nutrition space that are trying to teach our community about genetics. And I said, no. We're going to
genetics.
Yes, about genetics and epigenetics.
I would love to listen to some of this.
You should. But that's why I wanted to pull you in here to help me, wrap my head around it and clear it up. Because again, knowledge is so much power. And when individuals are struggling in their health and wellness, I think sometimes they feel like their disease or chronic disease is their current destiny. And I think understanding that we have control and the power of lifestyle modifications, and I love the study that you shared about who you're with, who you're exposed to. And I always talk about this with the kids. I always say, when we're together as a family, we've got to hype each other up. Our home needs to be a home that, really intentionally tries to build you up because there's so much that we're exposed to, maybe on the psychological aspect of it, but just environmental pollutants and mycotoxins and, stuff in our waters, you name it. We could go through the whole cycle. So anything to boost yourself as best as possible. Would you say if a person wanted to really improve their epigenetics, is it something that they do?
We don't say improve or change. Change epigenetics.
Ooh, I love that.
In science, there is no good or bad. Change.
So it's a variable. Ooh, you know what? I'm going to adopt that though, because I don't want people to just improve their diet. I want them to change their diet. I don't want it to be to lose weight, but to change their lifestyle and it be part. So I love this. So we always think of our genetics as who we are, but I'm looking at our genetics as who we are, is because it's the full expression of ourself, right? It's not just
genetics and epigenetics.
Yeah. The epigenetics lets us be a full expression of ourselves. So that's why it's not a dietary change to change the scale or reduce your cholesterol. It's a lifestyle change so that you can live your life to its fullest capacity. I like that. Dr. Nathanson, I always bring you in complex issues when we seem to be struggling in our community and we need really solid, sound science to help us ground ourselves in the decisions that we're making for our lives being based on reality. There's so much going on out there right now, and I love that there's so much discussion about lifestyle, about chemicals in our foods, what we should do. But for me, if we can ground it in solid science, like these conversations, we can go forward knowing that we're making the best decisions for ourselves and for our family. It's really good. So thank you for being here. Promise you'll come back. Good, because we need clarity from time to time. And I call you and I say, please come in and talk to us. All right, you guys, you heard it here. Make sure that you are working on turning on the positive things in your life and turning off the negative disease-causing things in your life. And that will make what we're made up of, right, have the best expression and the best life possible. Thank you.
Thank you.